And I'm glad to have you back for section 6.2. So today we're going to talk about factoring trinomials, particularly of the form x squared plus bx plus c. Next time in section 6.3 we'll learn how to factor ones that have another coefficient, we usually call it a, in front of this x squared term. So today we're just going to start with the basics here. Before we do that, I need to give you a little bit of a vocabulary lesson because I'm going to be using these terms throughout the course, so you need to be familiar with what they mean. A polynomial. A polynomial is a sum of terms of the form ax to the nth, okay, and I'll write this in just a moment, where a is a real number and n is a whole number. So first I'm just going to show you an example, and then I'll write the definition of a polynomial. But here's a quick example, something like 4x to the fifth minus 3x to the third power plus maybe a half x squared minus 1. That's an example of a polynomial because it is a sum of terms. You have 4 terms in this example where you have coefficients times variables to whole number exponents. Okay? So it's a sum of terms of the form ax to the nth, and you can kind of see that here. A is the constant, like the 4, the -3, half, -1, and x to the nth is a whole number. Now you can also have constants technically because x to the 0 is 1, so if n is 0, you're just left with a. Okay, so this is where a is a real number, which means it could be positive, negative, a fraction, a decimal, just a real regular number. And n, that exponent, this is key, has to be a whole number. In other words, it has to be positive integer or 0. Okay, a binomial is simply a polynomial with 2 terms. Bi meaning 2, so a binomial is a polynomial with 2 terms. For example, you could have x squared plus 3x. There's 2 terms. Or you could have x minus 5. That's got 2 terms as well. So a trinomial, you can probably guess, is a polynomial with 3 terms. And that's what this section is all about. See, factoring trinomials. So we're going to factor polynomials with 3 terms in this section. So for example, you'll see lots that look like this. 3x squared minus x plus 4. There's 1, 2, 3 terms there. But you could also have something like this, x to the 5th minus 4th x plus 2. That's a trinomial as well because even though it has x to the 5th, there's still 1, 2, 3 terms on it. So, okay, there's your vocabulary lesson. Now, first let's review expanding binomials. Now, I did this a little bit in section 6.1 and tried to kind of show you why we expand the way we do. So, first I'm going to do that, and then I'll show you the basically the shortcut rule, which you may have heard of. It's called FOIL. If not, that's okay. We're going to show you how to do that. Alright, so when you expand, remember if you expand something over parentheses, so I'm focusing on this set of parentheses right here, you have to multiply by everything in that parentheses. So I'm going to view this x minus 4 as a single factor. I'm going to multiply that out times the x and times the positive 3. So if I do that, I'll have the x minus 4 times the x plus that x minus 4 all times the 3 as well. Okay, now we can keep going with this because now we can distribute that x over those and this 3 over these. So when we do that, we get x times x, which is x squared, and x times negative 4 is negative 4x. Here we get positive 3x and minus 12. And then always look for things that simplify. And in this case, these 2 middle terms here do combine because we have negative 4x plus 3x. Those are like terms because they both have variables to the same power, just x and x, which means we can simply add the coefficients. So negative 4 plus 3 is -1, so this becomes x squared minus 1x, or just x, minus 12. So that's how you expand. Now, the shortcut here, the way people do it, is they multiply they don't usually do this step right here. That one usually gets skipped. So what they do is they multiply the first two terms together. X times x gives you that x squared. Then they multiply the second two terms together. So right here, I'm sorry, the outside terms together. So x times 3 gives you that positive 3x there. Then you multiply the inside terms, so the minus 4 times x gives you this minus 4x here. And then the last two terms, minus 4 times positive 3 gives you minus 12. So as you can see, we got all four of these terms by doing what I just did. So what I said was multiply the first two terms, then the outside terms, then the inside terms, and then the last term. So that's called FOILing. So it's for first, outside, inside, last is what that stands for. A little short on space here, but first, outside, inside, last. Those are the things that you multiply together, and then you simplify by combining any like terms that you have. So that's the shortcut, is to FOIL. Now that works if you have a product of binomials, meaning two terms and two terms, and they're being multiplied. So it'll always look like this, two sets of parentheses. Each set of parentheses will have two terms inside. Okay? So anyways, that's a review of multiplication. What we really want to do here, and the goal in this section, is to learn about factoring. Okay, so what we did was we got that their product is equal to x squared minus x minus 12. So from that, you know how to factor, because you know that when factoring is the opposite of multiplication, and when you multiply these two factors together, you got this. So therefore, the factored version of x squared minus x minus 12 is what we started with, which was x minus 4 times x plus 3. Okay, now we're going to learn how to do that, or how to find the factors if you're not given them in the first place in this section. But that is really what we're doing here. If you have two binomials, you can FOIL them, or in other words, expand them to get your trinomial. Or if you have a trinomial, it can be factored, often, not always, but can be factored into a product of two binomials. Okay, there's a little note here that says, not all trinomials, things like this, can be factored into a product of binomials. Not all can, but many can, and this is a common solving technique. Even as you go up through more and more math classes, factoring typically remains students' favorite method for solving later on, you'll see. So this is a great thing to do. It's going to help you all the way through as many math classes as you take. Okay, let's just start with an example on how do you FOIL. Okay, now how do you factor? When you factor a trinomial, it's always going to factor, if it factors, it'll always factor into a product of two binomials like this. Okay, so here we have a trinomial, we have three terms. So if it factors, it's going to factor into a product of two binomials. So we can start by just setting up parentheses, and I recommend just always doing that. Leave plenty of space inside, and always use pencil as well on this, because there's a little bit of guessing and checking involved. So you definitely need an eraser, because you may need to erase if you guess wrong the first time. Alright, so anyways, we can set up the parentheses here. And what we want to do is in particular, we want to look at the first two terms and the last two terms. And that's going to help us get the setup. Then the inside terms will come together. So the first two terms, see, when we multiply them together, we get this term right here, the x squared. Okay, which is exactly what we have here. We have an x squared here, which means the two terms that go here and here need to multiply together to give us x squared. Well, x squared only breaks down one way. It breaks down into x times x. So let's try putting an x here and an x here. Okay, now so far that works, because if we were to FOIL this, the first two terms would be, or the first term would be x times x, or x squared, and that's what we have over here. Alright, now let's try the last terms. Now the last two terms have to multiply to 20. Now there's a lot of ways to multiply two numbers to 20. So let's see. 20 breaks down into 5 times 4. It breaks down into 2 times 10. And it breaks down into 1 and 20. Those are all ways to factor the number 20. Now the one you want to go with is the one that's going to make this middle term correct, so that when you add the trick is to look at the two numbers and say which ones add to positive 9. I'm looking at that coefficient right there, positive 9. Well, 5 and 4 add to positive 9. So that's a good guess for which one is going to work. So I'm going to try putting positive 5 and positive 4. Okay, now remember this is a guess at this point. Then we'll check by foiling. Okay, so that's my guess. Now let's check. If we were to FOIL this out, the first two terms would be x times x, or x squared. That was these first two terms. Okay, then the next step is to do the outside terms up here on the foiling. So we'll do x times positive 4. You always include the signs, that positive and that positive. So x times positive 4 is positive 4x. Then next on the foiling is the inside two terms, which are the positive 5 and that x. Positive 5 times x is positive 5x. And then the last part of foiling is to multiply the two last terms together, which is this 5 and 4. Positive 5 times positive 4 is positive 20. Now, so far it doesn't look like what we started with, but if we combine these two middle like terms, 4x and 5x, and add those together, we get 9x. So this does work because we got exactly what we started with when we checked our answer. So the answer, or the factored version of x squared plus 9x plus 20 is this: x plus 5 times x plus 4. And the way you read that is quantity x plus 5, that implies that you have parentheses around it, times quantity x plus 4. All right, so that works, and this method over here will work with figuring out which numbers add to that middle coefficient. That'll work for polynomials in this particular section. When we move on to section 6.3, that will no longer work. So this only works, okay, this stuff over here only works if your first term is simply x squared, or a constant or a variable squared, where there's not a coefficient. It doesn't say 3x squared or 10x squared. It just says simply x squared. If that's the case, then this will always work. Okay, so we're going to do a lot more over here. All right, let's factor another one. You need some practice at this, so let's do another one together. All right, it's a trinomial. It has 3 terms, so if it factors, it will factor into a product of 2 binomials. So we'll go ahead and set up the parentheses. Now, the first 2 terms have to multiply to x squared. I'm going to put an F for first 2 terms. The last 2 terms have to multiply together to 6. And then the outside and the inside terms have to add to positive 7y. So, okay, let's start with the first terms. We can break down y squared into y and y. So let's put a y there and a y there. Then the last 2 terms have to multiply to 6. So let's break 6 down over here on the side. 6 can factor into 2 and 3, or into 6 and 1, and that's really it. So the question is, we want the middle terms to add to positive 7y. Well, these two are the two that add to 7. 6 plus 1 adds to 7. So really that should say plus, but 6 and 1 adds to 7. So let's go with the 6 and the 1. It doesn't matter which one we put where. We could put 6 here and 1 here, or we could put 6 here and 1 here, because remember, order doesn't matter. And everything is positive, so we'll have positive, positive. Okay, now let's check. If we FOIL, we have y times y, which is y squared. Then the outside terms are y times positive 6 is positive 6y. The 2 inside terms are positive 1 times y is positive 1y. And the last 2 terms give you positive 1 times positive 6 is positive 6. And these 2 middle terms, 6y plus y, add to 7y. So this is correct. So the answer here is this: y plus 1 times y plus 6. All right, so notice on those two examples that we just did, all the numbers on the trinomials are all positive. Each term has positive, positive, positive. Now it's a little bit different when you start involving negatives. The process is the same, you just have negatives going around, so it's slightly different. But the process is the same. So again, if this factors, it'll factor into a product of two binomials. So we set up the parentheses. The first two terms have to multiply to x squared, so let's try x and x. The last two terms have to multiply to 22. So let's see, 22 breaks down into either 2 and 11 or 1 and 22, and that's all I see off the top of my head. Now, what we want are two numbers that will add to negative 13. Well, neither of these adds to negative 13, but if you think about it, there's actually more ways to factor 22. Because we could not only multiply or factor it into 2 and 11, we could also factor it into negative 2 times negative 11. Because they're both negative, the negatives cancel when we multiply, and we still get positive 22. Now this is the one that's going to work because negative 2 plus negative 11 is negative 13. So let's go with negative 2 and negative 11. And let's see, if we FOIL this out here, we'll have x times x is x squared. This is just my scratch work here, checking. The last two, FOIL. First we do the first two terms, then we do the outside terms. X times negative 11 is negative 11x. Then the inside terms, negative 2x. And the last two terms, negative 2 times negative 11 is positive 22. And then you can see that these middle two terms, negative 11x minus 2x, do combine to negative 13x. So that is correct. This is the factored version of x squared minus 13x plus 22. All right, let's do another one. This one's a little different because the negative is in a different place. Up here it was in front of the second term. Now it's in front of the last term. But again, the process is the same. So this x squared will factor into an x and an x. Then we look at negative 36. Okay, what are all the ways to get negative 36? You could do positive 6 and negative 6. Or you could do, see, 12 and 3 will give you negative 36. So we could do 12 and negative 3. Or you could do negative 12 and positive 3. Other ways to get 36 could be 9 and 4. So you could do 9 and negative 4 or negative 9 and positive 4. So I think that actually will get us there because we're looking for numbers over here that add to positive 5. And I'm looking at, let's see, this one right here, 9 minus 4 is positive 5. So let's go with positive 9 and negative 4. All right, and if you FOIL that out, you'll get x squared minus 4x plus 9x minus 36. That does work. I'm going to let you check that one and make sure, but it will work. All right, so there's several we've done so far. Now here's another one. It's even a little bit more different because we have a negative in front of two terms, negative 3q and negative 40. So, but it works the same way again. So let's see. Let's break down this q squared into q times q. And negative 40, let's see, what are all the ways we could break down negative 40 that would add to negative 3? So let's see, 40 breaks down into 4 and 10, but I don't see any way how 4 and 10 will possibly add to negative 3, even if one of those two terms was negative. 40 could also break down into, let me write that down, what I just said. 40 breaks down into 4 and 10. So you could do negative 4, positive 10, or you could do negative 10 and positive 4. Okay, neither of those adds to negative 3, so those won't work. Let's see, we can also do 2 and 20. So we could do negative 2, positive 20, or negative 20, positive 2. That doesn't work. One that I another one here is negative 40 and 1, or negative 1 and 40, but those definitely are not going to add to negative 3. So we need some smaller numbers here. Are there any numbers smaller than 10 that are a factor of 40? Well, 5 is the factor of 40, so, and 40 divided by 5 is 8. So you could have -5 and +8, or -8 and +5. Now we're getting somewhere because we're looking for terms that add to -3. -8 plus 5 is -3. So this one should work if we do -8, +5. I recommend just always checking here, okay? So when we FOIL, q times q is q squared. The outside terms are q and +5 or +5q. The inside terms are -8 and q. And the last two terms are -8 times +5 is -40. And 5 minus 8q does equal -3q. So that does work for the factoring there. All right. This next one is again similar, but it looks a little bit different. Don't let it fool you. It's just really written in a different order. So if you don't like this order that it's written in, okay, where the y squared is the last term and the constant is the first term, we could just reverse the order. So that's what I'm going to do first. I'm going to reverse the order and write it as y squared plus 6y plus 15. That way it looks the same as all the other ones we've done. And let's give it a try. We can break the y squared down into y and y. The 15 we could break into 5 and 3. But 5 plus 3 is not 6. So let's see. Let's come over here. 15 breaks down into 5 and 3. Now if you think, look, are there any other ways to break 15 down? There is one other way, and that is to write it as 15 times 1, but that also doesn't add to 6. So no matter what you try putting here and here, your numbers are never going to add to +6y in the middle. So there's no way to factor this one. Alright, so this one is called a prime polynomial because it does not factor. Right, it does not factor, and that will happen on occasion. The more math you take, the more often that's going to happen too, but it doesn't factor. Alright, so sometimes that happens, but you really have to give all the numbers a try before you can decide for sure that this one just doesn't factor. Alright, let's try another one. Let's factor a squared minus 13ab plus 30b squared. Alright, this one's a little bit different. It's still a trinomial because we have three terms, 1, 2, 3. So the process is still the same. If it factors, it will factor into a product of two binomials. Okay, the first term has to multiply to a squared, so let's go with a and a. The last term has to multiply to 30b squared. Alright, there's lots of ways to get 30b squared, but both terms will have a b. You'll have a b and a b, and we have to make the coefficient here and here multiply to +30. So let's go break down ways to multiply to +30. Let's see. We could do, oh, and here's the other interesting thing. They have to multiply to +30, but add to -13. So if we want two numbers to multiply to a positive number yet add to a negative number, that means both numbers are going to have to be negative. That's the only way to get that, is to make both numbers negative, which is kind of like this one up here, this one right here, x squared minus 13x plus 22. The last term was positive, but the middle term, which was the one with the coefficient and just x to the first power, is negative, and so both numbers had to be negative. Okay, so we already know the signs. We can go ahead and put in minus, minus. Alright, so now ways to get 30. We could do -3 and -10. And actually that one works right there because -3 plus -10 is -13. So let's try a 3 and a 10. Alright, and let's check. If you FOIL, you get a times a is a squared. Your outside terms are a times -10b. That's -10ab. The inside term is -3b times a. That's -3ab. And the last terms are -3b times -10b. The negative times negative gives you a positive. 3 times 10 is 30, and b times b is b squared. Let's see, did that work? Negative 10ab minus 3ab. Those are like terms because they both have ab, ab. So if the variables are the same, you just add the coefficients. So negative 10 minus 3 is negative 13. So that does work, and this is correct. All right, this next one is a little different looking as well. Because we have an x to the fourth plus 10x squared plus 21. But it's still a trinomial, 3 terms, so the process is still the same. Okay, now if you see something like this with x to the fourth and x squared, it's usually, you're going to break down this x to the fourth, okay, into x squared and x squared. Now, there's actually a couple ways to do it here. X to the fourth could break down into x cubed and x to the first, or it could break down into x squared and x squared. But I'm going to go with the x squareds because we want the middle terms to add to something x squared. So let's go with x squared here and x squared here, and those do multiply to x to the fourth for your first term. Then for the last term, they need to add to 21, multiply to 21. So let's see, 21 breaks down into 3 and 7, and that works because 3 plus 7 is 10. So let's try that. Let's just try positive 3, positive 7. All right, if we try that with FOIL, x squared times x squared is x to the fourth. That's supposed to say fourth. There we go. It's supposed to say fourth. My pen's a little tough. And then the outside terms are x squared times 7 is positive 7x squared. 3 times x squared for the inside terms. And then the last two terms are 3 times 7, which is 21. 7x squared plus 3x squared is 10x squared. That works. All right, pause this and try the next one on your own before we do it together. But again, it's similar because it has all positive coefficients, so we don't have any negatives to deal with. Because the middle term is an x squared, let's break down this x to the fourth into x squared and x squared. And we can break the 12, let's see, we could do 4 and 3. Multiply to 12, but 4 plus 3 is 7, so that doesn't work. We could do 6 and 2. 6 plus 2, though, is 8, so that doesn't work. Or we could break 12 down into 12 and 1. 12 and 1 works because those add to 13. So let's try positive 12, positive 1. Okay, let's FOIL it. X squared times x squared is x to the fourth. X squared times 1 is just x squared. 12 times x squared is 12x squared. And 12 times 1 is positive 12. That works because x squared plus 12x squared is 13x squared. All right. A couple more here. 30 minus 31r plus r squared. This one, it works the same way. It's just written in backwards order, so it looks funny. Let's reorder it before we factor. So let's reorder it into r squared minus 31r plus 30. That looks a little better. All right, now let's factor it the same way we were doing before. R squared can break down into r and r. Then we need two numbers that but multiply to 30, yet add to negative 31. Now this is kind of like the one we just did in that the numbers have to add to one number greater than they need to multiply to. And if that's the case, we're just going to use this number times 1 because when you add this number plus 1, you get this number. Okay, so here we want them to multiply to 30 yet add to negative 31. So, okay, first dealing with the signs. If you want two numbers to multiply to a positive number yet add to a negative number, they're both going to be negative. And let's try 30 and 1 because when we add 30 plus 1, we should get negative 31 here. So if we FOIL this out, we'll get r squared. The outside terms give you minus r, inside terms are minus 30r, and the last terms are negative 30 minus 1 is positive 30. So these middle terms, negative r minus 30r is r negative 31r. So that does work. So r minus 30 times r minus 1. Okay, now this next one, we have x cubed plus 3x squared minus 4x. Now you can, if you look at this, it's a trinomial, so it's going to factor the same way. However, this one's a little different, and you probably noticed right off because you have a cube and a square and an x instead of a square, a constant term, and one with just x to the first power. So everything has an extra x in it. So if you try to break it down into a product of two binomials right off the bat, it's not going to work because no matter what you put, you could try breaking x cubed into x squared times x, but then there's no way to get 4x in the end if both of these are just constants, right? 4 and 1. Your last term will just be 4, not 4x. So there's no way for that to work. The trick is to always look for things that factor out of all the terms first. Remember factoring out a greatest common factor? We did that in the previous section. Try that first, then try factoring. Okay, and if we look, we can take out an x out of all three of these terms. If we do that first, okay, we take an x out of x cubed, we're left with x squared. And if we take an x out of positive 3x squared, we're left with positive 3x. And if we take an x out of negative 4x, we're left with negative 4. Okay, so all I did was take an x out, but now what's left here looks a little bit more like what we've been factoring. So maybe that will factor into a product of two binomials. So don't forget to carry along this first x. Okay, but I'm really only focusing on factoring what's in the what's underlined there. All right, so we want to factor x squared into x and x. Then the minus 4, so we want things that multiply to negative 4 yet add to positive 3. So if you want two numbers to multiply to a negative number, that means one of them has to be positive, one has to be negative. So we want numbers that multiply to 4 yet add to 3. So 4 and 1 sound good to me. If we make the bigger number positive, then the numbers will add to a positive 3. So let's try putting the 4 with the plus sign and the 1 with the negative sign. That way when we FOIL, now I'm not multiplying that out, x out, I'm just going to FOIL these last two terms. We'll have x times x, which is x squared. X times negative 1 is negative x. 4 times x is positive 4x. And 4 times negative 1 is negative 4. And these two middle terms here, negative x plus 4x, do add to positive 3x. So that does work. And let's do one more example in this section here. Again, this one, if you notice, has things that you can factor out of all three terms. And it'll always make your life easier if you look for the greatest common factor first. So we can factor out 3 x's, and looks like we can take a 5 out of every term too, because 5 is a factor of both 25 and 3 as well. So we can take out a 5x cubed out of everything. Okay, and then we'd be left with just an x squared on that first term. We'd be left with a negative 5x to the first on the second term because I took out 3 x's and I need 4, so I'm left with just 1. And if we take out a 5 out of negative 30, we're left with negative 6. And I took out all 3 x's, so I don't have any x's left there. And now let's try to factor this binomial, see if it can go any further. Maybe it can, maybe it can't, but you always want to try. So we'll carry along the 5x cubed. Always rewrite the whole problem every time. And then let's see, x squared breaks down into x times x. Negative 6. Negative 6 could break down into 2 and 3 or 6 and 1. And either way, you could get a negative 5. So let's write this out. Let's see, we want to get negative 6 when we multiply. So we could do positive 1 and negative 6, or we could do negative 1 and positive 6, or we could do negative 2, positive 3, or negative 3 and positive 2. So the question is, which of these adds to negative 5? And let's see, it looks like this first one here. Negative 6 plus 1 is negative 5. So let's try that. Negative 6 plus 1. And let's FOIL just this part right here to see if we got that part right. X times x is x squared. X times 1 is positive x. negative 6 times x is negative 6x, and the last terms are negative 6 times positive 1 is negative 6. So the inside terms, x minus 6x, do add to minus 5x, so that does work. And this is fully factored here. All right, so that is how you factor trinomials that when that first term there, the x squared, this only works if that doesn't have any coefficients. Okay, so I hope you've seen plenty of examples here. You can practice this in the homework and we'll learn how to do more complex looking things that have an ax squared on the next lesson.